All right, so here's our next example. Suppose n is 400, x is 140. If we construct a 90% confidence interval and a 99% confidence interval, the question is, which has the larger margin of error? And based upon our previous discussion, I think it should be clear. Which of these, keeping everything else equal, which of these has the larger margin of error? It should be clear the 99% has the larger margin of error. To illustrate that, and just to practice, let's compute both of them. We're going to compute both of these, and we should then, once we have that, we should be able to clearly see that the 99% confidence interval has the larger margin of error. So, why don't you do that? Pause now and do those two computations. All right, hopefully you did computations. Let's see if I can catch up to you, see if I can get my work to be as accurate as yours. So, what do we have? We need p hat is x over n, which is 140 over 400. 140 divided by 400, and I have that to be 0.35. And we have q hat, 1 minus p hat, 0.65, right? And we want a 90% confidence interval. Again, from our special table. And again, I'll just hold it up so we can see pretty nicely. We want a 90% confidence interval. The number is 1.645. So z alpha over 2, 1.645. And so what do we have here? We have p hat plus or minus z alpha over 2, and that's square root p hat q hat over n. P hat we computed to be 0.35 plus or minus z alpha over 2 was 1.645. P hat we've already computed to be 0.35. Q hat 0.65 over the square root, what do we need, 140? And so that's 0.35. Now, p hat doesn't change. Of course, that has nothing to do with the confidence level. That's simply the computation we get from the given information. So, if the question is, how does the point estimate change from 90% to 95% or 99%? The answer is there is no change. The confidence level has no effect on the point estimate. The confidence level, the only place this 90 or 99% comes into play is in this number, and that's in the margin of error. Notice this doesn't change either. This is the same. So that's why we say keeping everything else equal, changing this confidence level changes only this number. It only affects this margin of error. So getting back to it, 1.645. And then I have 0.35 times 0.65 and divide that by 140 and then take the square root of that number. I have, again, I'm going to round this to 0.040. And I'm going to clear and use this rounded number in my computation from here on out. This is plus or minus 0.35 plus or minus. So I'm going to take 1.645 and multiply that by 0.040, and I have 0.0. I'm going to round that to 3 decimals again. So this is round off error accumulated extraordinaire, 1.66. So for a 90% confidence interval, 90, the margin of error is 0.066. Let's make a little note here. 90%, it's 0.066. I'll do exactly the same computation down here at the bottom of the page using a 99% confidence interval, 0.35. Really, we don't even need this computation to answer this question about the margin of error, but for the record, here we are. And our table value for a 99% confidence interval, the thing is, these values never change. And so you'll see these numbers occurring over and over and over and over again. You'll get used to them. You get used to 2.575. And 1.96 occurs over and over and over again. So 2.575 is the number we're playing with. And notice this number has not changed. I'll go ahead and fill the details in, but this number has not changed. We could just as well throw in the 040 immediately because that value is not going to change. But for the record, 0.35, 0.65 over 140, and so that's the 0.35 plus or minus 2.575. And so we amazingly get 0.040 again, same number. And now I'm going to multiply that out, 0.35 plus or minus 2.575, and multiply that by the 0.040, and our value is 0.103. So the margin of error is 0.103. If again, and in a percent, this is 10.3%. So when we did a 99% confidence interval, the margin of error was 0.103. Again, you can think percent. You should write decimal, but we can think percent. This is 10.3%, a 10% margin of error. This is only about 6, maybe 7% margin of error. So 6.6% margin of error as opposed to 10% margin of error. We expected that. Keeping everything else equal, a higher percent confidence level gives a larger margin of error. A lower percent confidence level gives a smaller margin of error.